Hello and welcome back. Today we're going to be talking about graphing linear equation application. The objective is by the end of this video you should be able to graph and find the domain and range of a problem situation and identify graphs that will show just points or graphs that will show lines. Which leads us into our first two definitions. A continuous function forms a graph that you can trace without lifting your pencil off of it. For our purposes, let's look at the line in red. The line in red would represent a continuous function because I could trace that line in red, so I could draw a straight line without lifting my pencil off of the line. However, a discrete function would just be a series of points. Notice you cannot go from point to point and trace just the points without lifting your pencil up off the paper. Also, a discrete function has to have completely separated points. It's going to be slightly important later on. Let's take a look. Suppose that you and your 4 friends want to go to Breckenridge, Colorado for a ski trip. You all have saved enough money for the resort, but you're trying to decide if you have enough money for gas. Gas costs about $3.50 a gallon, and the total cost can be represented by the function CG equals 3.5 G, where C is the cost and G is the number of gallons. You and your friends have saved $200 for gas, make a graph, and find a reasonable domain and range for the function given. I'm going to scroll down to where you see just the equation, and the reason I'm going to do that is because since they give you a function, that's what you're going to want to focus on. And just like in the previous video, we're going to use this equation in order to make a table and then draw a graph. First thing I like to do is identify what the variables are in relation to our normal axis. So since y is usually by itself, we know CG equals 3.5g. We can rewrite that as y equals 3.5x. So C is going to be y, the cost, and g will be x. Now you and your friends have saved $200 for gas. That means that which value will be $200? Will that go in for the number of gallons or the total cost that you have to spend? The answer is that will be a y value. So immediately we can start thinking about the domain and range for the function just by thinking about the money we have to spend for gas. We've got $200 for gas, and we know that our cost has to be less than or equal to $200. So our y values have to be less than or equal to 200 as well. Let's think about a lower range. Our upper end is 200. What's our lower end? Or is there a lower end? Can you spend negative money on gas? Well, the answer is no, so we know that it has to be bigger than 0. So our y values go from $0 all the way up to $200, which is how much we have to spend. So now that we have our y's, let's find our x's. To do this, we're going to make an xy chart. But this time we have y values, not x's. So we know our y values go from 0 to 200, and since it's a linear function, 3.5 times x, we only need 2 values to draw our graph. How do we find our x values if we know our y values? And the answer to that question is make an equation. Our y values are equal to 3.5 times our x values. So if y is 0, we can solve for x by dividing both sides by 3.5. 0 over 3.5 is 0. So we know that if y is 0, x is also 0. Well, what if y is 200? Then we end up with, so y is equal to 3.5x. We end up with 200 is equal to 3.5x. We divide both sides by 3.5. and we get a fairly random number. It's 57.14. The question before we write that down is, can you have 57.14 gallons? The answer is yes, because you can have any number of gallons, including decimals. They don't just make you buy a whole number of gallons. So we have 57.14. Now that we have our two values, we can go ahead and draw our graph, and then again write our domain and range. Since our x values are all positive and our y values are all positive, I'm just going to use the positive ends of the x and y axis. And since we're talking about real amounts, I'm going to label my x and y axis based on the amounts that they actually represent. The x is going to represent gallons, and the y is going to represent the cost. Our y values go from 0 to 200. So I'm going to make a mark for 200 here, and make a halfway mark for $100, and that should be sufficient for this graph. What about number of gallons? We're going to go all the way up to 57.14, so I'm going to go count by tens: 10, 20, 30, 40, 50, and 60. So 57.14 is right about here, so we're going to go up to 200 and draw a point. Over here we have the point 0, 0. So we can go ahead and draw our graph by connecting those 2 points. And here we have the graph of our function, from $0 to $200, from 0 gallons to 57.14 gallons. So we have our range. What about our domain? This is our range, our y values. Our domain have to be related to the x values. And our x values have to be less than or equal to 57.14 or greater than or equal to 0. Because you notice the x's are between 0 and 57.14. Here's a problem for you to try on your own. Go ahead and read it to yourself, pressing pause, work it out, and when you're ready to see the answer, please press play. I went ahead and split away the function from the rest of the information, since that's what we're going to focus on. And I like to rewrite my functions as x and y. Not necessary, but it just helps me keep track of what we've done in the past versus what we're doing now. So y equals 40 plus 0.5x. Y is the average. X is the test grade. And you want an 80 for the 3-week period. An 80 average is what you're looking for. So our y value is going to be 80. Notice you want at least an 80. That means that's the smallest amount that you want for the 3-week period. What's your upper limit for the 3-week period? We're going to assume that it is a 100, that the highest grade the teacher can post in the gradebook is a 100. So, how are we going to find a table? The answer is just like we did last time, make an xy. And we do have y values. Our lower range is an 80, our upper range is a 100. All we need to do now is find the x values, graph it, and write our domain and range. If you didn't get this far, go ahead and find your x values by solving the equation for x given the y's. Okay, for the first one, you should have gotten 80 equals 40 plus 0.5x. You subtract 40 from both sides, and you get 40 equal to 0.5x. Divide both sides by 0.5, and you get x is equal to 80. For the second one, you would have done the exact same process, except instead of putting in 80, we're going to put in a 100 for y. Again, subtract 40, and 100 minus 40 gives us 60 equals 0.5x. To get x by itself, we divide both sides by 0.5, and we get x is equal to 120. Which means that the scores we're looking for in order for you to have an 80 average are between an 80 and 120. Is it okay for you to have 120 grade on a test? Well, in this example, it is okay because we were told in the problem that we assume you can earn extra credit on the test. I know that's a very large grade, but we're just going to go with what we're given. You go ahead and draw a graph. And if you use this little symbol right here, it's like a little squiggle mark in your graph. It's not very prettily drawn. It lets the reader know that you're going to skip some values. We're going to start at 0, 0, and we're going to go up to our first y value, which is 80, and our second y value, which is 100. And over here, we're going to get our x values, which is 80, and I'm going to count by 20s. 80, 100, and then 120. So we plot our points, 80, 80, and 120, 100. And we connect our 2 points with a line segment. So that line segment, all the points on the line segment, represent all the possible grade values you can have. Again, this is our average. And these are our test grades. We already have our range given to us for the y. Let's find our domain. In this case, our domain starts at 80 and goes all the way up to 120. Here's one last one for you to try. Please press pause, read the example, and work it out on your own. I went ahead and split away the important information, rewrote the equation as a function of x, and now we're going to go ahead and make a table. In this case, we were actually given the x value of 5. We just need to think, how far up and down can our x values go? Well, you're thinking of renting up to 5 movies, which means your x values have to be less than or equal to 5. And you can't rent negative videos, so your x values have to be greater than or equal to 0. Which makes it pretty easy. We're going to go from 0 to 5 movies. So if you rent 0 movies, how much money do you spend? Well, you spend 0. If you rent 5 movies, how much money do you spend? You spend $20 because it's 4 times 5. So we can make ourselves a graph. Again, we only need this portion of the graph because all of our values are positive. And we're going to go from x0 to 5. And my y values, I'm going to count by 4 since it's $4 per rental. 5 videos cost $20 and 0 videos cost $0. You may have connected those 2 dots with a straight line, but the reason I introduced discrete functions at the beginning is that this is actually an example of a discrete function. Now, why? The answer is you cannot rent half of a movie. You have to rent a whole movie, which means we can only increase by single amounts every time. So our function is actually going to look like a series of dots because you can't, again, rent decimal movies in between those values. So your domain is actually going to be 0, 1, 2, 3, 4, and 5. Your range then, I'm going to write your range up here, is going to be $0, $4, 8, 12, 16, and 20. Again, the reason this one was a little different was because you could not rent a decimal amount of movies, which created, in the end, a discrete function.